All right, guys, so we are still on the topic of decimal. And so we're just going to move in now to converting decimals, fractions to decimal. Have we done anything of this sort as yet? Anybody?
No, sir.
I haven't done this with you yet, guys. Not hearing any response. Have we done this yet? No?
No,
Yes?
sir.
All right, no. All right, so we are continuing on the topic of decimal. Now, converting, we may have done some conversion of decimals to fraction. Can anybody recall that? Anybody recall we do the conversion from decimals to fraction? All right, if you cannot recall, let me do a few of those so that it's a general idea. And then now we will convert from fractions to decimal, all right? So, good evening. Is that Shay?
Yes, sir.
Let us look at some conversions of decimals to fractions. Say, for instance, we are given the number 0.75. And you are told to convert this to fraction. How do we go about this? Anybody? Anybody could give me an idea how to convert 0.75 to fractions? Anybody remember what we say a decimal is? Go ahead, Miss Clark.
Okay, sir. The 0.75. So if you look at the after the point, the 7 is the in the 10th place, the 5 is in the 100th place. So you look at the one that is furthest out from decimal, so it's going to be 75 over 100, and then you simplify that. So you can say
all right, so let me just write what you're saying. So you're saying that we are to look at, go ahead, look at the digits furthest from the point.
Yes. So
and what does that tell us?
75 over 100. 25 is in the 100.
How do you determine that it is over 100?
Because the 5 is in the 100th place, and you put the 7 and the 7 and the 5, you're going to say 75 over 100.
Okay. I am a little hesitant to call it hundreds place. It's really hundredth with a T.
Yes.
All right. All right. So general rule, guys. Remember, we say that decimals are special fractions, and the fractional parts come after the decimal point. And we know that the first digit would be over 10th with a TH, and the second digit would be over 100th with a TH. Now, what we know is that the number of digits that comes after the point help to determine, will allow you to determine how much 0 is in that powers of 10. So if you have 2 digits after the point, then you would put all of this number. How many zeros you would have in the powers of 10? Anybody?
1.
2.
2.
So if you have one digit after the point, it would be over 10. So let me just break that down so that we all understand what is happening. So if we have 0.7, then we have one digit that comes after the point. So it means that that first digit after the point will be over 10. So remember now, the 0 here tells you that you don't have any whole number. So it means that is only the fractional part you have. So if you have one digit, this place value is over 10. So we would have 7 over 10. Now, if we have two digits, 0.75, then now it will also tell you how many zeros in the powers of 10. So if you're up here, you have one digit, then down here we have 1 0. If now we have two digits after the point, then in the denominator, what we're going to have? How many zeros we're going to have?
2.
2 zeros, right? So the number of digits that come after the point determine how many zeros are in the denominator. Now, in this case, the two digits must go over the 100. So this would become 75 over 100. All right, so now that we write it in the decimal fraction, because these are denominators in powers of 10. So these are still in the decimal fraction. How can we now change these into regular fractions? Or how could we find simpler forms to these fractions?
So you would simplify.
All right. When you say use 75, what you say 75?
Yes, sir.
Before we jump onto that, can this fraction appear? Can this simplify it any further?
No, sir.
No, sir.
Can it be any simpler than it is? No. So for this one, we're going to leave that one as it is because we cannot simplify it any further. When we are simplifying a fraction into its lowest term, what we are doing, we are finding numbers that we can cancel numerator and denominator with. And once we can find that, then we find that when we cancel it down, we get a simpler fraction. And that simpler fraction will simply be what we call an equivalent fraction. So equivalent fractions are exactly the same size fractions. They are only in different forms. Let me see the hands of those who understand what I'm saying.
Sir, can you repeat one more time, please?
Okay. All right, let's just look at the second scenario now. Down here we have two digits after the point. And we say that that number of digits will tell you how many zeros you have down here in the powers of 10. So two digits after the point means we have 2 zeros in the powers of 10. Now, having written the denominator with 2 zeros, now the numerator going to be the same two digits that we have after the point. So we put these in the numerator. So 75 over 100. Now we are now seeking to simplify this fraction into a simpler fraction. So in order to do that, we have to find a number that can both go into the numerator and denominator without a remainder. So when we find that number, we can simply cancel down. Now, the best number to use is the highest common factor. The highest common factor would be the highest number that can go into 75 as well as 100. Which number would that be?
25, sir.
25. So if we use 25, we would divide the numerator by 25. So we say 25 into 75 give you how many times?
3.
3 times. And for the denominator, 25 into 100 goes
4.
4 times. So this fraction would be simplified into 3 over
3/4.
Right. Now, this fraction 3/4 would be the same as the fraction 75 over 100. So these two fractions are exactly the same. 75 over 100 is the same as 3/4 in terms of their size. They're the exact same size fractions. However, they are written with different numerators and denominators. But because they have the same exact size, we say the fractions are equivalent fractions. So they are actually the same, but they are written with different numerators and denominators. Is that clear to everybody?
Yes, sir.
Yes, sir.
All right. So now this is how we generally convert our decimals to fraction. So let us try another one to ensure that we're getting the hang of this. All right, so suppose we have 3.25 and we want to convert that into fractions. Well, how we go about doing that?
3 and 25 over 100.
Okay, so we would write 3, the number that comes before the point, to write that as a whole number part. So we have 3, and the number that comes after the point, those now we are going to put them over the respective powers of 10. So which powers of 10 we're going to put this over? 10 to the which power?
Second power.
Second power. That means the denominator going to have how many zeros?
2.
2.
Zeros. All right. Once you write the respective powers of 10 down here, then come after the point, you write them back as a numerator. So that would be 25 over 100. Now, all that remains for us to do now is to simplify this 25 over 100 into a simpler form, into an equivalent fraction. So what we can do here is to do what? Find a number that can divide both the numerator and the denominator without a remainder.
25.
In this case, we can use 25. 25
Yes.
itself goes 1, and 25 into 100 goes 4.
4.
Here now we write back the whole number, and we write back the fractional part. So this becomes 3 1/4. And so that's the general way how we convert decimals to fraction. Is that clear to everybody?
Yes, sir.
Right, so that's it.
Yes, sir.
Let me see the hands of those who are comfortable with this. All right. Let me see the hands of anyone. Let me see the hands of anyone who is not so comfortable and you'd like me to just do another one. All right, so I'm taking it that everybody is comfortable then. All right, so let us now do the opposite of what we have been doing. So we have just looked at how we convert decimals to fraction, but now what we want to be able to do is to convert fractions back to decimals. Now, I'm going to use one of the the fraction that we just derived. So I'm going to use back the 3 1/4. And now what we want to do is to convert this to decimal. Now, I know we would have known what the number is already. But what I really want to do is to go through the procedure of how to get it back to that number. So anybody have any idea that you'd like to share with us of how we can convert this number to this fraction to decimal? Anybody?
So you divide the numerator by the denominator.
All right. You divide the numerator by the denominator. Well, so we could do it one out of 2 ways. We could just write back the whole number part, and then now, because we know that that would be the whole number. And then now the fractional part, how would we convert that?
Flip it upside down.
Flip it upside down? No, that wouldn't be the case. Somebody would have said it prior to that. What somebody said, divide the what?
Numerator
By the denominator.
All right, so in this case, we have 1/4. We want to convert it to decimal, so we would, if we take the long division approach, we would have the division bar, and inside the division bar, what would we have under the division bar? Which of these numbers we're going to have under there?
The one.
Yes, the 1. And so outside there, we're going to have what? The denominator. So the denominator is always outside here, because in this we are really dividing the numerator by the denominator. Is that clear to everyone?
Yes, sir.
All right, so somebody can walk me through that step now. Can we go through this division process here now? Who want to help me? Raise your hand if you want to help me through this process. Anybody? All right, so Ms. Waysome, can you assist us?
Sir, repeat, because they were breaking up. Sorry.
Okay, I just want somebody to help me to carry out this division, the procedure of how to divide this.
Okay, sir. From the way I remember it, sir, you'd say 4 into 1, you can't, so you'd put a 0.
Okay.
Sir, are you hearing me?
Yeah, man, I'm hearing you. And then what?
No, sir, you would have a 0 at the top as well. You
have a 0.
So, yeah, I think yes, sir. And a point, and then after the point, and then we'd say 4 into 10, so it goes 2 times.
All right.
Sorry.
Yeah, man, I'm hearing you, but I'm going to clear this. I'm going to work with this one. Let us start off with 3/4. All right. So Ms. Waysome, you want to still walk us through it?
Sure, sir, no problem.
All right. So we say that we would put the numerator here. and then we put the denominator out here. Is that clear to everyone?
Yes, sir.
Go ahead now and tell us what to do, Ms. Grayson.
All right, sir. So we say 4 into 3, and we can, sir. So that you would add a 0 at the top, sir.
All right, so add a 0 at the top.
Yes, sir. A point. So I'm just allow me to do it now. Yes, sir. And then we'd add a 0 to the 30 as well.
To the 30.
To the 3 to turn it into 30. Yes, sir.
Okay.
Then we'd say 4 into 30, 4, 7, 28, 7 times.
Okay.
So 4, 7 is 28.
What do we do with that?
We put the 28 below the 30, sir. And then we take away 4, 7, 28, sir, not 27.
Oh, sorry. 20. All right, so
28 from 30 leaves 2.
2.
Yes, sir. We say 4 into 2, we can't, so we add a 0 right there to make it 20. And then 4 into 20 goes 5 times, sir.
So we put what?
And
Yeah.
and then 5 times 4, 20. We put the 20 below and we take away, and that would be it.
Okay. All right, so that's the procedure. Is everybody okay with this? Let me see your hand.
Sir, please work another one.
I am going to work another one. In fact, I'm going to work more than just one. Because my aim is to get you to understand what you're doing and why you're doing it. All right. Can you explain to us, Ms. Wilson, what you did and why you did it? Are you there, Ms. Wilson? Let me see the hands of those who understand what was done here. Or probably should I say, let me see the hands of those who don't quite understand what was done. All right. Okay. All right, so you see, that's one of the problems that sometimes happen with math. Sometimes we learn a procedure, but we don't know why we do the procedure. So you have what we call procedural understanding, but you don't have a conceptual understanding, meaning that you don't understand the idea behind what you're doing. All right, so that's what I'm going to try to get you to understand now. All right, so I'm going to look at another number. This time we're going to use 7/8. I want to convert this to decimal. Now, I'm going to ask all of you, based on the procedure that you just saw, try to do this one, and then now I will do it and clarify for you. So I'm just going to give it 2 minutes to work this out, and then I will go through it with you. Try it, guys.